Continuing on this line of thought, there are many ways to interact with devices. Two of the most common approaches is explicit I/O, having explicit I/O instructions, or having memory mapped I/O. And both approaches are basically two ways to talk to I/O devices. And while no one of them is superior to the other, the architecture you're using, the hardware architecture you're using, and your operating system will dictate how you will handle I/O basically. So, for example, the in and out instructions on the x86 is sort of maps to sort of read write are explicit I/O instructions that basically reads and writes from any I/O device. So you basically have to specify which I/O device you're talking to, and what is the data you're going to write in, or what is the data you're going to read out from that device driver. The second common way to perform I/O is memory mapped I/O. And if you remember in the beginning of the lecture, we talked about the devices having three registers: status register, a data register, and a command register. Memory mapped I/O, what you do is that these registers are added for each device. They are added to your virtual address space. Sorry. They are added to your virtual address space. So the hardware makes device registers available as memory locations, basically. And in this case, what you need is that as a CPU, when the CPU tries to talk to the different devices, it will talk to them in the form of as if it's talking to memory, just like as if it's part of your virtual memory. And there are no additional instructions required. So if you use memory mapped I/O, you can actually use it without any additional instructions, and you just need to know how to handle the devices. Basically, when you add them, they need to be added to your virtual address space somehow, and you need the operating system to basically facilitate this. The device driver is what the operating system uses to facilitate this communication between the CPU and the different parts of the computer system to the device that you just added. I'm sorry, it's hitting me very hard now. So if you have already been exposed to the device driver concept, if you have even touched the Linux kernel module project, and there, I mean, in the video lecture that I have uploaded, and in the slides, you will actually find some details. But the idea is that you want a way for the operating system to communicate with the different devices that you're going to add to the system. Imagine, for example, you have your computer that has an SSD drive, an HDD drive, USB drive. Basically, sometimes you might even have the operating system loading from the USB, like when you're basically installing Linux. One way to install Linux, and also Windows, is through USB stick. So that's even sometimes your primary or the main place where your operating system resides. You want your computer to be able to deal with all of these different disks that connect through different interfaces, through different hardware interfaces, in the same way, providing you basically with the file system interface, files, directories, and so on, so that you can deal with. Okay? And you would like to be oblivious to all the details. You really do not want to basically, when you put in a USB stick, you do not want to start basically all of a sudden using a different way to open a file or to save a file. You just want to click save, and you just want to double click on the file to open it. Device drivers are what provides you with this abstraction, and at the lowest level, it's a piece of software that the operating system uses to basically know how to deal with the different devices. And this piece of software is not really part. I mean, some people might view them as prefer peripheral to the kernel, since they are not really part. They are not really part of the kernel in some cases. They even come on the kernel directory, on the Linux kernel directory. You find them in a separate folder, all of them. But and if you're doing the LKM project, then you know that you can build basically a mouse driver using that, and if you can basically hook up your own device drivers as much as you want. So the Linux file system looks like this. You basically have a device driver at the bottom, which is basically can be SCSI, 88, USB, whatever, and you have the device driver basically managing all of these details. How does SCSI different from 80? And if you don't know what SCSI is and what 80 is, these are two different interfaces. Like when you basically have USB and USB-C, right? Or when you have HDMI and DVI, right? There are many of these interfaces, and devices come in all shapes and forms. And basically, internally also, SCSI devices from 80A devices, they differ also as hardware. But I mean, how are they connected is part of it, and so on and so forth.